software engineer at Huggingface. First of all, I'd like to thank the GLOSAIC team for organizing this conference and for inviting me to speak. Today, I'm excited to introduce you to FastRTC, a powerful new Python library that makes building real-time audio and video AI applications incredibly simple. In the next couple of minutes, I'll show you how FastRTC solves a critical problem in the AI space, making real-time communication accessible to Python developers. Let me set the stage. Over the last couple of months, we've seen an explosion of real-time AI models, from OpenAI and Google's live multimodal APIs to open source models like Moshi, Qwen 2.5 Omni, and Ultrabox. What we're seeing is that AI models are able to understand audio and video in real time, which is an incredible achievement. But despite these advances, building real-time AI applications that stream audio and video remains challenging, especially in Python. This is because ML engineers don't know about WebRTC and WebSockets, which are the fundamental technology needed to build low latency audio and video streams. Moreover, building conversational applications where humans and LLMs naturally take turns speaking is really challenging because it requires implementing voice detection and turn-taking algorithms that are not in the toolbox of your typical ML engineer. Moreover, you can't really vibe code your way into a low latency audio video streaming app. I've tried several times and the LLMs consistently get this wrong. So those failures are part of the reason why I decided to start FastRTC, just because it was way too difficult to even get off the ground. FastRTC drastically changes this landscape by providing developers a high-level Python API that can turn any Python function into a low latency audio or video stream over WebRTC or WebSockets. Moreover, FastRTC abstracts away the voice detection and turn-taking algorithms, so you can quickly get started building conversational applications with any LLM. Moreover, FastRTC comes with easy-to-use text-to-speech and speech-to-text utilities, so you can get started without needing to set up any external APIs or anything like that. You can do any sort of audio-related tasks already with FastRTC. So before we jump into some code, I want to give everyone a high-level view of how FastRTC models conversations so that you have the necessary context to understand the code we'll cover later. So in this case, there's two entities. One is the human, and the other is the FastRTC application. So when the humans are speaking, FastRTC will stream the audio to the FastRTC server. That server will run some voice activity and turn detection algorithms to be able to know when the user finishes speaking. When the user finishes speaking, FastRTC will automatically detect that and pass it to this box here called the Python function. So the Python function is what you, the developer, have full control over. So here, you control the logic for how you turn that user audio into generated audio that the user will hear. Then FastRTC will run your function and send it back to the user. And then the cycle will repeat and repeat. And this Python function can pretty much do whatever you want. And you can, you don't have to just return audio. You can return a video stream. You can return a chatbot UI. You can do pretty much anything you want. But that's like a high level of how the application is built. So without any further ado, let's see how this all comes together in building a Llama 4 application. So I have my code editor open here, and let's go through building an application following the schematic I showed before for interacting with Meta's new Llama 4 model. So at the top here, what I'm doing is creating a text-to-speech and speech-to-text model, or importing them rather from FastRTC. So these two models are what's going to let Llama 4 understand the user audio. The other thing I'm doing here is instantiating a client that I can use to call Llama 4 via API through Huggingface. And now the guts of our logic is going to be, the guts of our application will be this response function. So this response function is that Python function box I showed earlier. So what is this function going to do? It's going to be pretty straightforward. It's going to take the user audio and transcribe it with that speech-to-text model. Then we'll format it for the API and get the response from the API. And then we're going to yield a stream of audio using the text-to-speech model. So this is what's going to be the response the user gets is here. And then we're also going to return the chat message response so that we can display it in a chatbot UI. So that's the Python function box. Now comes the FastRTC box I showed before. So all that takes is just wrapping our response function in this reply on pause helper, and then passing it to the stream class from FastRTC. And then the only little thing we'll do is just tell it that we want to display this in a Gradio chatbot. And then all we have to do now is just call UI.launch, and we can play with this right in our browser. Okay, so now that I've called UI.launch, I have this Gradio UI locally I can use to test my application. So let's get started. I'm just gonna grant access to my microphone so that FastRTC can stream the audio to the Llama 4 model. Hi, how are you doing?
I'm doing well, thanks for asking.
Do you know how many people have walked on the moon?
12 people have walked on the moon.
So we just saw how every FastRTC stream has a built-in Gradio UI that you can use to test your application. But you don't have to stick with Gradio if you don't want to. It's possible to mount any FastRTC stream into a FastAPI application and deploy it however and wherever you want. So here I've taken that same Llama 4 application we built earlier and just mounted it onto FastAPI and serving a more custom UI that way. And just a final note on deployment, these apps are really easy to deploy on Huggingface spaces. So that's what I typically like to do. So now to start to wrap things up, we've been talking a lot about audio streaming, but it's also possible to do video streaming with FastRTC. So this is a real-time object detection application that's built with FastRTC. So you can see it's running in real time, and this is it's not client-side; it's sending the stream to the server and back. So we have really low latency thanks to the WebRTC. It's also possible to do audio and video streaming at the same time. Let's see an example of that with this animated Einstein avatar.
Ah, hello there. The beauty of mathematics and physics lies in their power to explain the universe. You see,
I cut him off there, but that was really, I always love playing with him and asking him questions. Okay, now finally, I want to show you guys like the final cool feature of FastRTC, which is that you get a free phone number to call into your audio stream. So if you have a Huggingface token, instead of calling UI.launch, you can just call .fastphone, and that will give you a free temporary phone number that you can use to call into your stream. So obviously, one of the primary ways that audio AI is being deployed is over the phone to automate a lot of tasks that are usually bottlenecked by people. So what I'm going to do is I'm going to call this phone number and type in this code to be able to talk to our Llama 4.
Followed by the pound sign.
Okay, so I'm going to put in the code.
Connected to the AI assistant.
Hi, this is Freddy.
Hello, Freddy. Nice to meet you.
So that's really cool and convenient and really easy to get started deploying however you want. So just to wrap it up, please follow our org on Huggingface, so huggingface.co/FastRTC. Here you'll see all of our demos, as well as some docs. And then for the complete docs, please go to fastrtc.org. You'll see everything I covered in this talk more in depth, as well as some other cool things that you can do with FastRTC that I didn't have a chance to talk about. So thank you guys so much for your time, and yeah, I'm available to answer any questions you may have.
Awesome. Let me bring in actual live Freddy now. What's up, Freddy?
Hi,
Awesome
everyone.
demo. That was super interesting. Also, thank you everyone for asking interesting questions during that. Is there any, and we have a few minutes left, is there anything that, you know, watching yourself kind of go through that back live that you want to add to what you covered?
Yeah, so I think like the kind of like one of the highlights that I want to get across with FastRTC that wasn't super clear with the video is that everything that you saw there was like fully open source. So the text to speech, the speech to text, Llama itself being a like open weights model. So you can do like really incredible things that like rival like the OpenAI or Gemini real-time API just with like an open source stack and running locally as well. I mean, except for the LLM, but if you had like Llama CPP or something, you could create that whole stack locally. Yeah, so it's like really cool. It's really exciting. I definitely think that like audio and video are like the next frontier that LLMs will start to dominate. So yeah, like get in now, basically. So and obviously, I think FastRTC is the easiest way to do it, especially if you're like a Python person. But yeah, like super excited to see you guys in the Huggingface Discord or on GitHub, you know, building with this, asking questions.
We have like a couple minutes left. I had one question for you. You know, you focused in the demo a little bit more on like conversational AI, but you sort of mentioned like it can pretty much do whatever you want, including video streams or like different UIs. It struck me while you were talking that the library's kind of core capabilities, like low latency, real-time streaming, you know, turn detection, kind of align really well with like gaming and VR. I was curious how you see FastRTC being used kind of beyond conversational AI, if that's what you guys talk about.
Yeah, I mean, it's something that I haven't thought about too much yet, just because I think like the lowest hanging fruit is just nailing down this conversational interface, which I think it's like, you know, the community has started to like align on best practices. So, I mean, as we start to nail it down, I think we'll move to like the next bit, which yeah, might be like autonomous like meta avatars in like, you know, like Fortnite or something, right? That like can kind of you can, you know, like kind of to your point of like that you can do anything. Like when I showed their Llama 4, that could be like an autonomous agent by Llama 4, right? So it's like FastRTC doesn't really care. Yeah, so it could be like, you know, yeah, like, you know, with you in like your iPad as you like cook, right? And it can see your screen and it can like tell you like guide you through a recipe, or it could like, you know, whatever, be like a Einstein physics tutor or something. Yeah, so I think like all of these things kind of like need the conversational approach. So that's kind of like the bedrock. But yeah, like I think once this tech really starts to get adopted and people start to use it, like I think like the sky's the limit.
Awesome. Well, thank you so much for putting that together and for being part of GLOSAIC today. Really appreciate it, Freddy.
Great. Thanks for putting it together.